Alright, 6.1 today. Hey, we're on our journey in trig, and we're at the last chapter of trig. So if you like trig, oh so sorry, it's the end. If you don't like trig, then yeah, it's the end. Let's just quickly go back and talk about what those primary trig ratios were. I think we remember what those were because we learned those like way back in grade 9, 10. Yep, sine theta, cos theta, tangent theta. And I think in one of our previous chapters we learned those reciprocal identities. That would be the cosecant theta, which was 1 over sine theta. There was also secant theta, which I hope you remember is 1 over cosine theta. And then there was the last one, cotangent theta, which equals to 1 over tangent theta, the reciprocal trig ratios. Okay, I'm calling them identities now because both sides of the equation have the same value for all the permissible values of x. Okay, and the expressions on both sides of the equal sign are the same. So if I were to look at cotangent theta, that's equal to 1 over tangent theta. They're the same. Remember about tangent and how we used to define tangent in terms of sine and cos? Remember that identity? And if you do, write it down. Tangent theta was equal to, any guesses out there? Yeah, sine theta over cosine theta. Well, similarly, we can use the reciprocal identity and the above to find an identity for cotangent. Cotangent, once again, is just 1 over tangent, which really means it's 1 over, and we just said tangent was sine over cosine. That looks kind of messy, so we just flip it around. That's just cosine theta over sine theta. Okay, so these identities, the tangent theta being equal to sine theta over cos theta, and this other one, cotangent theta, being equal to cosine theta over sine theta, well, they have special names too. They're called quotient identities. Quotient because you're doing a division. Okay? So for the first part today, I'd like you to use this identity that we just created. Cotangent x equals to cosine x over sine x. And I want you to first of all determine the non-permissible values in radians for this equation. And I hope you remember that non-permissible values come when we have a denominator. And lo and behold, we have a denominator. It's sine x. And so in this case, sine of x cannot be equal to, that's right, you can't have the denominator being equal to 0. So therefore, I'm asking you, where are the non-permissible values? So where is sine x equal to 0? Well, if you're not too sure, think back to chapter 5 and actually just sketch out the sine graph. Whee! Right? There's the lovely sine graph. This is 0. That must be pi and 2 pi. So it looks like it's 0 at 0, pi, 2 pi, and so on, so on. If I wanted something in general form, then I would strongly suggest it looks like it's just multiples of pi, so pi n. Okay? Maybe not general formula, but general form. Okay? Alright. Well, we found the non-permissible values. Supposedly this identity for everything besides these values, so let's actually verify this to see if it's actually true. Okay, I'm going to ask you to numerically verify that the identity is true. By the way, I have x up there and I have theta here. Remember, x and theta are interchangeable. Okay, so x just equals to theta. So what I'm going to ask you to do here is going to use this identity. So cotangent of, I guess in this case, pi over 6 must be the same, and I'm going to show you hopefully that it's true. Cosine pi over 6 divided by sine pi over 6. Okay, I'm going to do these two things separately. The left hand side I'll do over here. Cotangent is the same thing as 1 over tangent. So that's tangent pi over 6. I hope you remember your special angle table, because tangent pi over 6, I believe, would be what? Tangent 30. I think that's, what is that? Oh yeah, 1 over root 3. Okay, if you don't remember that, go back to those previous chapters. And I think that just simplifies to root 3. Okay? Well, if I were to use the right-hand side now, so right-hand side, Cosine of pi over 6, that from my special angle table, I believe is root 3 over 2. Sine of pi over 6 from my special angle table, which I hope you remember is 1/2. And when you're dividing here, that's the same thing as multiplying by the reciprocal. The 2's cancel out, and I'm left with root 3. Hey, the left side's root 3, the right side's root 3. They're the same. I like it. We verified it. Okay? We can do the same thing for angles and degrees. It's the same thing. So once again, let's try this. Cotangent of 120 degrees now. That should be equal to cosine of 120 divided by sine of 120. So we'll do the same things, and I'm going to ask you to try to evaluate this. 1 over tangent 120. Well, tangent 120. I think that's the same thing as tangent of 60. And because this is in the second quadrant, this is negative. Hope this stuff is good for you. This was from chapter 4. Tangent 60, I believe, is just root 3. So all I have here is negative 1 over root 3. Do the same thing with the right-hand side. So cosine 120 is the same thing as cosine of 60, but it's negative because it's in quadrant number 2. Sine 120 is the same thing as sine 60, but it's positive. Cosine, I believe, was negative 1 over 2. And then sine is positive root 3 over 2. And of course, if you just do the division, that's 1/2 times 2 over root 3. Once again, the 2's cancel out. And lo and behold, it's the same as the left side. Yay! Should be the same. And that's how you numerically verify that they're solutions. Okay? Alright, the next part is to now use technology to graphically decide. So why don't you pull out your graphing calculators, and I'm going to ask you to sketch the graph of the left side, which is cotangent x, and the right side, which is y equals cosine x over sine x. And let's graph and draw the two, and let's see if they're the same thing. Okay? Pull out your graphing calculator, I'll pull out mine. Okay, hold on. Okay, so I've got my graphing calculator here. Ooh, some lagging. Gonna turn mine on. Go to y equals to, erase all this other stuff that I have here. Wow, lots of stuff. Erase, 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 erase. And I'm going to ask you to plot cotangent. Now, there's no cotangent button on your calculator, so you have to use the trig identity 1 divided by tangent theta. Make sure you're in radian mode, so I'm going to check that. I am. Good. I guess I'm going to zoom. I'm going to zoom trig, I believe. Zoom trig. That goes from negative 2 pi to 2 pi. And there's my graph. So I'm going to sketch this here. Okay, so wee, and then what do I see? Oh, a whole bunch of asymptotes. Asymptotes. Let's see, there's one right here. I'll use red for the asymptote. Another one here. 1, 2. How do I see? 1, 2, 3. I guess I see. 1, 2, 3. And then the graph goes like this. Okay, that's what I see for cotangent x. Now, let me see if it's the same thing with cosine x over sine x. So I'm going back to my graphing calculator. Going to erase that. Going to type in cos x divided by sine x. And let's see what picture we get. Doesn't this look like the same thing? It looks the same to me. So, because it's the same, what I've done now is visually proven or confirm that cotangent x seems to be the same thing as cosine x over sine x. Yay. Same. Okay? And that's how you verify things, both graphically and numerically. Alright, turn the page. So, knowing that, I'm going to ask you in example number 2 to actually just find me the non-permissible values. So first of all, tell me where this problems occur. And then from there, I want you to actually simplify these nasty trig functions. Maybe you can simplify them into one trig function. Okay? So, let's look at this. Well, part A, you don't see a denominator, so you might be thinking, oh yeah, there's no non-permissible values. Well, guess again, okay? Because I think tangent can be written as sine over cos. Cosecant can be written as 1 over sine. And then now we have cos. So now I'm thinking, look at this here, and I've got cosine theta can't be 0. And I've also got sine theta, which can't be 0, for my non-permissible values, your NPVs. Okay? Well, where's cosine not equal to 0? Well, once again, I just like to draw out these graphs. Cosine seems to be at like, I think it's pi over 2, 3 pi over 2, and so on. So the general formula I think would be just, well, I didn't leave much space there, did I? Ha ha ha. Let me erase sine. So you can say something like this: pi over 2 plus 2 pi n, n is a whole number, 3 pi over 2. Remember, we have to write down, plus or minus I should say, if I'm using whole number. I have to actually write all the different possible values. Same thing with sine then. Sine graph, starts in the middle, so I think that's just like 0, pi, 2 pi, etc. So in general form, how about just pi n, where n is an integer? Okay. Your NPVs for part A. Okay, we'll go back to what we have, and how do we start simplifying? Well, I hope now you can see that, hey, the sines, they can divide each other out to 1 and 1. This cosine here is the same thing as cosine over 1, so, oh yeah, those all cancel. And so your answer here is actually equal to 1. Yes, all that work for 1. Alright, let's try the next one. You might be thinking, where's my denominator here? Well, notice I've got 1 plus secant x. So for your non-permissible values, how about 1 plus secant x not being equal to 0? Therefore, secant x can't equal to negative 1. Secant x is the same thing as 1 over cosine x, which can't be equal to negative 1. Therefore, cosine x can't be equal to negative 1. And that occurs, if you think about the cosine graph, I believe that occurs at pi. And so the general formula would be pi plus, I think, 2 pi n. N is an integer. Okay? NEI. Let me write that nicer. Now you're thinking, hey, that might be the only one. Guess again, there's another restriction somewhere. And if you're not too sure where that comes from, well, let's start simplifying. Okay? 1 plus cosine x, I don't think I can simplify that, but the secant I can rearrange as 1 over cosine x. So bam, here's another fraction with a denominator. In this case here, look, your denominator is just cosine x, so I guess cosine x also can't be equal to 0. And we solved that before in part A, so I'm just going to copy the answer again. So x cannot be equal to pi over 2 plus or minus 2 pi n. And of course, it also can't be equal to 3 pi over 2 plus 2 pi n, where n is a whole number, or n is a whole number. Okay? By the way, I guess I should go back to be careful. These should always be not equal to, because these are non-permissible values. So theta can't be. Okay? Sorry about that. Okay, back to simplifying now. You might be thinking, oh, this is like fraction over fraction, yuck, yuck, yuck. My suggestion to you for this one here is in your denominator to continue to rewrite that as just one fraction. So I'm going to make it all over cosine x, which means that first term of the 1, in order to have the same denominator as cosine x, that should be cosine x. Okay? So you just see what I did there? Cosine x, cosine x. Once again, this part is the same as this part here. Okay? I'll continue simplifying because this now becomes 1 plus cosine x, and the bottom now becomes cosine x plus 1 all over cosine x. And then dividing is the same thing as multiplying by the reciprocal. So I'll just take 1 plus cosine x. Going to multiply that by the reciprocal, which would be cosine x over cosine x plus 1. And notice how the cosine x plus 1 here seems to be the same as over there. So I can take the entire thing and divide them out. So that's 1 and 1. And this simplifies just to cosine x. Yay. Alright, so I've given you a sample of how we can use these trig identities to help us simplify these complicated trig expressions. Well, I'm going to ask us to go back in time to section 4.2 when we talked about the unit circle. Remember this picture here? Remember a unit circle was really just a circle with radius of 1 unit? That's why they call it unit circle. Well, how would you go about finding the equation of this unit circle? Don't know if you remember us doing this. We had a point, called it x comma y. We drew a nice triangle, a right triangle perhaps. This is x, this is y. And then we said Pythagoras, oh yeah, x squared plus y squared. And since that equals to the hypotenuse, and this is a unit circle where the radius is 1, this was equal to 1 squared, and therefore we said that the unit circle had an equation x squared plus y squared equals to 1. I remember that. I hope you do too. But wait a minute. Don't you remember another way of expressing x and y's in terms of sine and cos? Do you remember that x was equal to cosine of theta and the y value was equal to sine of theta? Yes, that's all from chapter 4. And if you did that, then something kind of mysterious happens here. Okay? Because the unit circle, okay, could be now cosine theta squared plus sine theta squared equals to 1. Okay? Now, by the way, people in trig, when they say cosine theta squared, I hope you remember this. This is the same thing as writing it as cosine square theta, because that indicates that you're taking the whole entire thing of cosine theta and squaring it. Okay. Similarly, I think sine theta all squared can be written as sine squared theta. And so a lot of times what we have here, and you'll see this in your textbooks, is they'll write down instead of cosine theta all squared, they'll use cos squared theta. And then instead of sine theta all squared, they'll use sine squared theta. And by the way, most textbooks use the sine one first for some strange reason, but they do. Sine squared theta plus cosine squared theta equals to 1. Okay? This is very important. It actually has a special name. It's one of these Pythagorean identities. Of course, why, you might be asking? Because Pythagoras kind of came up with this, right? Now, that's just one of the Pythagorean identities. There's actually 2 more. And I'm going to ask you to figure that out now on page 3. Alright, so here's your exercise. I'd like you to use what we just did there, sine squared theta plus cosine squared theta equals to 1. And I'd like you to actually find the other 2 Pythagorean identities yourself. It's not that hard, because I actually gave you a hint. But let's try anyways. Sine squared theta plus cosine squared theta equals to 1. Now in part A, I'm going to ask you to take every single term and divide it by sine squared theta. Okay? Let's see what happens when you do that. Well, sine squared theta divided by sine squared theta, yeah, that's easy. That's just 1. Cosine squared theta divided by sine squared theta. Now, what's cosine over sine? If you said that's cotangent, you are absolutely correct. So this must be cotangent squared theta. And then 1 divided by sine. Well, that's cosecant. Cosecant squared theta. Done. There you go. That's one other one. I'm going to ask you to try the next one on your own. We're going to start the same way though, okay? So sine squared theta plus cosine squared theta equals to 1. Go ahead and you try. But this time, divide by cosine squared. Sine over cos. Yep, tangent squared. This is 1. And that must be secant squared theta. And ladies and gentlemen, there you have it. The other two Pythagorean identities. One is 1 plus cotangent squared theta, and that gives you cosecant squared theta. The other one is 1 plus tangent squared theta, or tangent squared plus 1, and that equals to secant theta. Okay? I'd like you in example number 3 just to verify all 3 Pythagorean identities are true using the angle pi over 3. Okay? So, use number 1. I want you to verify that's true. I'll ask you to use number 2 using pi over 3. I'm just writing them out again for you. I'm going to let you try this on your own because it's very similar to example number 1. And I think this will be good practice for you anyway. So please try. Don't be lazy. Okay? I know many of you are, but please don't be lazy. You got to spend the time to work on this to make this your own. Okay? All right. I'll be quiet now. You go try this with theta equals to pi over 3. Special angle table. If you don't remember that, sine pi over 3, that's 60. That's, I think, root 3 over 2. Pi over 3, yeah, that's 1 over 2. Does this equal to 1? I think it does. Yay! 1 equals to 1. Yay! Sorry. Getting too excited. Okay, you try the rest. I'll be quiet. Shh. This one works too. Cosine pi over 3. Cosine 60. I think that's a half. It works too. Whew. See you next section.